Lastly, we have a problem, or we have a question on number 141 from section 5.1 on page 329 of your textbook. So this problem is going to read as 9mp plus 3mq minus 3np minus nq. Hopefully you guys can read that. I'm doing this with my finger. So again, because you have four terms here, so your first term is going to be this 9mp, your second term is going to be 3mq, your third term is this negative 3np, and your fourth term is this negative n times q. So we have four terms. It doesn't look like there's anything in common between all three. So initially you might think, oh, I can factor out of 3, but if you notice that your fourth term here does not have a factor of 3 in it. Likewise, not all four terms have an m in them, nor do they all have a p, nor do all of them have a q. So again, what we're going to want to do is we're going to factor by grouping. So I'm going to couple these two together, and then I'm going to go ahead and couple these two together. And again, I'm going to treat this as two individual problems, and then once I'm done, pull it all together. So from here, I'm going to note that I have a 9 and a 3, so I can pull out a factor of 3, and I also note that I have an m situated in each term, so I can factor that m out. So knowing that, I would be left with a factor of 3p plus q. From here, let's go ahead and take a look at our second couple. And note here that we have a negative 3, and we don't have anything here other than a negative. So I do know that I can pull out that negative, and I can pull out that n. Okay, so recall from previous examples that we did in class that if we see a negative in our lead term, we want to pull that negative out. Okay, so if we do this, then we would check and we would note if I pull a negative out and an n, I would just be left with a 3p. And if I pull a negative n out, recall that the sign flips, and I just have a q in this case. Lo and behold, hopefully this is not going to come as a shock, but when we look at these two terms again, as indicated by these boxes, we have a 3p plus q in each term. So since they have a 3p plus q in common, I can factor out this 3p plus q, and then you just basically again play the game, what do you have left over? Well, I have that 3m left over from here, and then I have this minus n left over from here. Lo and behold, I have my final solution that I have boxed in gray for you. If you want, you can do a quick check to make sure that you did do this correctly. So we would FOIL that out, and that's going to give you 3p times 3m, so that's 9pm or 9mp. Then we would do 3p times negative n, which is going to give you negative 3np, and then we would continue to FOIL. Q times 3m would give us positive 3mq, and then I would do q times negative n, which is going to be negative nq. And again, let me go ahead and rewrite some of this so that this kind of makes sense. So 9pm, again, we have the commutative property for multiplication, so I can still write this as 9 times m times p. And then I was able to write the rest of these as we see these terms noted in the problem above. And it's really just a matter of using your commutative property for addition to make sure that this problem matches the one that you started out with. So we do have a 9mp. Do I have a positive 3mq? Oh, I do. I just forgot to make that positive. So we have plus 3mq. I have a negative 3np, and then I have a negative nq. So it does check out. I did get back to my original problem, so that means that the answer that I do have boxed in gray is the correct solution. Alright, so there is the solution for number 141 on page 329 of section 5.1.